so what we are looking at a projection. So when an object is projected, it will project at an angle with an initial velocity, let's say v. And then what we're going to do is we're going to separate this part into two separate components. We're going to look at two separate components. In the y component, which goes up, and the x component, it pushes this way. So the way we write this is Vy and Vx. So that represents the horizontal component, and this represents the y component. How can we separate it into that? Because you can see that, imagine this ball, it just goes up because what is pushing it up is the initial velocity. Now, and what is pushing it in this way is also the initial velocity, but it's the x direction that is causing it to move this towards this way, and it's the y components that is causing it to go up. That's why we can separate it into two different components, and we look at each one separately.
When you say x component and y component, is the equation always in terms of v?
No, we're going to look at three different equations. The acceleration in terms of the x component, the velocity in terms of the x component, and the displacement in terms of the x component. And then we look at the y one, and then we look at the acceleration in terms of the y component, the velocity, and then the displacement in terms of the y components. So we're going to be looking at these three different equations: acceleration, velocity, and displacement in separate components. So in this case, that is the horizontal one, and this one is the vertical one. Okay? Why is acceleration a constant? Because in the x component, because if it's not constant, then the path would not be a parabolic shape. So imagine, so in other words, there's a force that is acting on the horizontal component. So it will it can look like this. Okay, it would not be a parabolic shape because something is pushing it. So imagine this in a horizontal point of view. So in this case, so you can see that, you know, if there's a force that is pushing it this way, then the path eventually goes back that way. Okay. Now, if there's a force that is pushing it in that way, then the path will actually goes down like this. It wouldn't be a parabolic shape. And this will be air resistance, because air resistance could be like at an angle. That's why we're not looking at that. If there's no force acting on it, then the acceleration in the x direction equals 0. So that's why it will form a perfect parabolic shape. Okay. Now the vertical acceleration is minus g. Where is the acceleration? So where should say g is the acceleration due to gravity. Now let's look at, in terms of the y direction, you can see that if you throw something up, as we talked about, it's only under gravitational force, and that is directly pulling it towards the ground. And you can see that it's because of that force that the paper ball eventually goes back onto the ground. Okay, if you throw something, why does it go back onto the ground? Because of that gravitational force, right? Imagine there's no force in space, you expect it to go back on the ground. No, it just flies up because there's no force pulling it anyway. Okay, and gravity is always directly down towards the ground. Okay, so G represents the magnitude, negative represents the direction because it's towards the ground. So we represent that one as the negative direction and up as the positive direction. That's why we have that minus there. Okay, that's why it's minus G. So what can you see in terms of, what can you express? So you can see that sine theta is equal to opposite Vy over hypotenuse, which is V. Okay, so in other words, Vy, which is the velocity in the y component, is equal to V sine theta. Yes? Now the next one, cos theta is equal to Vx over V. Okay, so in other words, Vx is equal to V cos theta. Okay, so what have we done here is that we express the initial projection, the initial angle of projection and the initial velocity into the y component and the x component. So the y component can be expressed in terms of v sine theta, and the x component is v cos theta. And this is when t equal to 0. Okay, because this is the initial value for these two separate values. Okay, now let's coming back in. How do I find x dot? Yep, so we integrate 0. So remember, this is velocity. How do we find this velocity? We are given acceleration. We integrate the acceleration to get velocity, right? With respect to time. So what do we get when we integrate 0? And how do we find a constant? With this, because when t equal to 0, which is initially, we are sure that we're looking at the x, the velocity in the x direction is equal to this. So we have Vx, or x dot, equal to v cos theta. So therefore, you can see that C1 equal to v cos theta. Therefore, x dot is equal to v cos theta. The vertical component, we have y dot, which is the velocity in the y direction. And how do we get that? We integrate the acceleration in the y direction with respect to time, then we get the velocity in the y direction. So we get minus gt plus d1. Okay, of course, every time you integrate, you get a constant. Okay, use different values to represent the constant. Now, when t equal to 0, what does y dot equal to?
V sine.
Yep, so when t equals 0, you can see that vy, which is y dot, equal to v sine theta. That's the initial velocity in the y direction. So you can see that if we substitute this in, we have v sine theta equal to 0 plus d1. Therefore, d1 equal to v sine theta. Any questions? Don't you like to ask like a common question? Do we need to know this for the exam? Yes, you do. You need to be able to, I'm serious, you need to be able to, work all of this out in the exam.
Do we need to know them off by heart?
Off by heart, yeah.
How can we just figure them out?
I would like you to understand why each step is like that in that case, so that you will understand. So you can, do each question from scratch, but after you do this for a while, you get used to it. Okay, see this thing in the box. Now in the HSC, although knowing all of this is part of the course, like part of the syllabus, but in the HSC, they don't actually need you to, like in the last 5 years or so, they don't like you to regurgitate all of this, but they will actually give you, these two equations to start with. They like to give you the equations to start with, and then you answer the question. Okay, so these are the two equations. If they are not given to you, you actually need to prove it. So in school assessments, I know that they don't like to give you the equations, so you need to do all of this. But in HSC, they will give you the questions. See, what is the difference between parametric and Cartesian equation? Parametric equation is x in terms of a parameter, y in terms of a parameter, but the Cartesian equation is x and y in terms of the same equation. That's the difference between Cartesian and parametric equation.